focus on adding linear expressions, which is going to be lesson 6, okay, of chapter 5. In your book, it will start on page 395. Actually, we're just going to take note of the one vocabulary word that you have in this lesson. You'll be able to note underneath your vocabulary that it is linear expression. So please take a moment on your vocab web and make sure that you do get linear expression, the definition in your own words, and an example put into that. Okay, we're going to go ahead and jump into page 396. What I'm going to do today is basically kind of take a look at some examples that are in the lesson, but for the most part, one of the things that I'm going to do is pull away and actually go and grab some really specific practice problems that you guys will be able to do along with me, either in your book on the side or on a piece of notebook paper, to kind of help you out a little bit more. The more that you can practice adding linear expressions, the easier it will become for you. Okay, so first and foremost, when we're talking about linear expressions, it is important to understand what an actual linear expression is. Okay, first thing that you want to understand is it's an algebraic expression, and we've been talking about algebraic expressions. So again, we're going to be working with numbers, variables, operations, okay, combination of all of them, and the variable is raised to the first power. Okay, it's kind of important that you remember that we're going to be working with it raised to the first power. So what that means is if I have 6x, okay, that is raised to the first power. Maybe I have 5x minus 2. X is being raised to the first power. If I would write out 3x squared, okay, that one is not going to work because it's actually being squared and it's not raised to the first power. So our goal is going to be focusing on working with variables that are being raised to the first power, okay? The other thing to think about is in a linear expression, if it's linear means that it's going to form a straight line, okay? So if you would go and graph it eventually, which what we are going to do, okay, it would end up being a straight line format, all right? One of the examples that they give you first and foremost here is you're supposed to add 2x plus 3 and then plus x plus 4, okay? They do show you using algebra tiles. They model it for you, so you can kind of see what they're doing. They start off with having 2x's plus 3x's here, and then I'm adding another x and 4 ones here. Ultimately, what we want to do is combine our like terms, okay? So we would combine our 2x's and our 1x here to get 3x's. I would combine my constant of 3 and my constant of 4. So my 3 ones plus my 4 ones would give me a total of 7 ones. So overall, after I add linear expressions, my overall answer would be 3x plus 7. Okay, please note that today on this lesson we are just focusing on adding. Okay, next, in terms of adding the two expressions, you may have subtraction of what the actual linear expression is, but you're going to be adding them together. Next one, we have 2x minus 1 plus x minus 5. In this example, they did not use a model, so we're just looking at our situation here. Okay, again, you've got 2x's plus another x here, so I have 2x's plus another x would give me 3x. Here I have 1 negative, and I have 5 more negatives to add to it or to put together. So if I have 1 negative plus 5 more negatives, that would give me 6 negatives. So when we rewrite this expression and we add it together, we're going to have 3x's minus 6. Okay. They give us a couple practice problems on the bottom of page 396 that we're going to take a look at, and then I'm going to redirect you to a worksheet where we're going to look at some other ones. When I take a look at this, technically this problem is saying the same as 3x minus 5 plus 2x minus 3. Okay, so this will go back to our last lesson where we were putting them in simplest form and combining like terms. So when I look at my situation and what I have that's common or what that's alike, I've got 3x's and 2x's, so 3 plus 2 gives me 5x's. And then I have 5 negatives and 3 negatives. So negative 5 plus negative 3 would give me 8 negatives. You can write that as 5x minus 8 or 5x plus negative 8 means the same thing. Okay? Next one, again, I'm going to take out my parentheses there, so I have 2x minus 4 plus 3x minus 7. So looking at what's alike, okay, or what my like terms are, 2x's and 3x's, so I end up with 5x's, and then I have a negative 4 and a negative 7. If I have 4 negatives and then I'm adding 7 more negatives to it, That's going to give me 11 negatives. So I could write it as 5x minus 11, or I could have 5x plus negative 11. Okay, so there's a couple examples that you have in your book. What I'm going to recommend that you take out is a piece of paper right now so we can work on some of these practice ones together, or otherwise on the side column of your book you can follow along there. As we take a look, okay, what I've done is I've just pulled a practice worksheet that we're just going to pull a few of these problems, okay, to kind of take a look at to get some practice of how we would add linear expressions. Okay, so I'm going to start at the top here with number 1. Okay, as I take a look at number 1, we have 9x plus 7 plus x plus 3. Again, if I'm working with this one, what I'm going to do is I'm just going to rewrite it as 9x plus 7 plus x plus 3. So the first thing you want to ask yourself is, what are my like terms, or what can I combine together? I know that 9x's and 1x here, so I have 9x's plus another x would give me 10x. And then I also know that I can combine my constant of 7 and my constant of 3. They're both positive, so 7 plus 3 would give me 10. So in simplest form, when I add them, I would have 10x plus 10. Let's take a look at number 2. Negative 4x plus 6 plus x minus 5. Again, look at your like terms and what you can combine. I've got an x, negative 4x, and an x there. So technically I'm thinking negative 4 plus 1. Negative 4 plus 1 would give me negative 3, so I have negative 3x. And then I have 6 and negative 5. So 6 minus 5 would be a positive 1. So in simplest form, okay, that would be my answer for that one. If it helps you to go ahead and underline or circle or put a square around or maybe color code what your like terms are, please do that. You will notice that when I'm solving mine, a lot of times I underline or I will circle or color code, put a rectangle around or a square around to kind of help me remember what I can combine together. What I would like you to do right now is to take a couple minutes and go ahead and pause the video. And on your worksheet, I would like you to try question number 3 and question number 4. All right, as we take a look at the 2 examples that I had asked you to work with, the first one, number 3, we had negative 3x plus 15 plus negative 3x plus 2. So what I did was rewrite it without the parentheses. So I have negative 3x plus 15 plus negative 3x plus 2. I've underlined my x's, so I'm thinking 3 negatives plus another 3 negatives would be 6 negatives. And then I have plus 15 and plus 2. 15 plus 2 would give me 17. So my overall answer is negative 6x plus 17. As I take a look at number 4, again, I went ahead and had written it down without the parentheses. So negative 2x plus 10 plus negative 8x minus 1. I underlined my x's. I'm thinking negative 2x plus negative 8x. They're both negative, so I'm going to go ahead and add them. 2 negatives plus 8 negatives would give me 10 negatives. And then I have 10 minus 1, or 10 plus negative 1 would be plus 9. So we should get negative 10x plus 9. There are a few other practice problems. I will move this down. Okay, and so if you would like to at this time, you can go ahead and feel free to copy down any of these other practice problems that you see, that you see on this page. And you can go ahead and work through those. If you choose to go ahead and work through these, that's fine. When you're finished, just go ahead and let myself know, and then I will be able to check those with you. All right, next thing we're going to go ahead and look at are a few other practice problems, again on page 397 in your book. Basically, this is just a continuation of adding your linear expressions, so I'm just going to pick a few of these. Letter C, and what happens here is they're just becoming basically a little bit more extensive. You're going to notice here too, for example, they're incorporating the distributive property. Okay, same thing right in here. So I'm going to focus on letter E and F to start off with and kind of work through those together. You can go ahead and work through the other ones, C and D. If you choose to, if you need to pause, you can go ahead and pause and work on those. But I want to talk about E and F first of all. So if you remember, okay, 6 is on the outside, so we want to think about the distributive property. Because this 6 is on the outside, we're going to multiply by each term on the inside. So if I'm thinking 6 times x, that's the same as 6x, plus 6 times 7 would be 42. Then I would have plus x plus 3. Now I can go ahead and combine my like terms. I have 6 x's and 1 x there. 6 plus 1 would give me 7 x's. Plus, and then I have 42 plus 3 would be 45. So in simplest form, okay, these original expressions where we were adding them would equal 7x plus 5. Let's take a look at this one. We have 12x plus 19 plus, again, I'm using my distributive property, so 2 times x is 2x minus 2 times 10 is 20. Be careful with your subtraction signs because remember those do represent negatives, so you have to be careful of them. Now I'm going to go ahead and combine my like terms. 12 plus 2 would give me 14x. And then 19 minus 20. 20 is larger and I have a positive and a negative, so we actually subtract. 20 minus 19 would give me 1, and because 20 has a larger absolute value and it's negative, that means it's going to be a negative. We could also write that as 14x plus negative 1, as that would mean the same thing. Okay? Again, just adding in the distributive property on letter E and F, and then working through the addition of it. Feel free to go ahead and do C and D. If you choose, you can pause to do those and then check those out. The last thing that I want to take a look at here in your video is the top of page 398. We just have a practical application at the top. Real life situation here. Number 6 says, write a linear expression in simplest form to represent the perimeter of the triangle. Find the perimeter if the value of x is 5 centimeters. So there's 2 parts to this. Number 1, writing a linear expression, and number 2, we're going to find the perimeter if the value if it is x. One of the things we have to remember is what perimeter means. Remember, perimeter means the distance around a figure, okay? So when I take a look at my triangle over here, this side represents 3x minus 3, plus this side is 2x plus 9, plus this side is 5x. So again, because it's perimeter, I'm going to be adding up all of my sides. So I've taken this linear expression plus this linear expression plus this linear expression. Then we're going to go ahead and combine our like terms. So 3x's plus 2x's would be 5x's plus another 5x's would be 10x. I've got 3 negatives plus 9. Well, negative 3 plus 9 would give me a positive 6. Then, so I have my linear expression. Okay. Then my next job is to find the perimeter if the value of x is 5. So they are telling us what they want x to equal. So I'm going to plug in 5 for x. So I'm thinking 10 times 5 plus 6. So 10 times 5 is 50, plus 6 should be 56. And we're looking at perimeter, and it's measured in centimeters. So therefore our perimeter should be 56 centimeters when x is 5. Okay, and we can kind of see here if that's what they have, and that's what they have as well. Okay, taking a look at letter G, we're looking at a rectangle. Okay, so we know on a rectangle, we're going to have 2 sides that are the same. Lengths are going to be the same, widths are going to be the same. The job is to come up with the perimeter. So if I think about this, I have 2 lengths. So technically I can take 2 times x plus 4 plus, I'm going to have 2 widths. So 2 times 2x minus 2. Again, using your distributive property, so 2 times x is 2x plus 8 plus 4x minus 4. Combine like terms, 2 plus 4 would give me 6x. And then 8 minus 4 would be a positive 4. So my expression should be 6x plus 4. And then what they want us to do is to plug in 7 for x. So I'm going to take my expression 6x plus 4. I'm going to plug in 7. So 6 times 7 would be 42. Plus 4 equals 46. And my label is feet. So therefore, okay, our perimeter when x is 7 should be 46 feet. Our linear expression should be 6x plus 4. At this time, you can go ahead and take a look at your webpage for lesson 6 and take a look and start working on your practice problems, which should begin on 401.